Today we are going to discuss the exam of Manipal University BEB Basic of Electronics. So this is the midterm basically. Okay, I am telling the midterm. All the MCQ based question I have targeted. MCQ based question. This is from the paper of 28th September 2023. Okay, September 2023. So you will get the duration for the MCQ based question is 20 minutes. Okay, so let's start. Let's read the first question. In the first question, they have said an op-amp has a voltage follower, has a voltage gain. Voltage follower, first of all, you should know what is basically a voltage follower. In the voltage follower, the input is connected with a negative terminal and feedback is also there with a negative terminal. But in this we don't have any resistance. Here we'll give the input voltage, we'll get the output voltage, and in this case, as you can see, it's a non-resistance circuit, so output voltage would be equal to the input voltage. So this is the exact diagram of the voltage follower. Now they ask you to calculate gain. As you know that gain is represented by A, and the formula for the gain is output voltage divided by input voltage. So if both the voltages are equal, then gain would be how much? V out by V out is 1 only, and 1 we can say it for the unity, right? So technically we can say the voltage gain for the op-amp as a voltage follower would be unity. This is particular for the voltage follower only. Okay, this is question number 1. Now next move towards question number 2. This is from the CMRR. In this they said if the differential voltage gain and the common mode gain of the differential amplifier is this, the common mode rejection ratio is. Common mode rejection ratio is denoted by CMRR and its formula is 20 log base 10 AD divided by ACM. Okay. So AD is the differential gain and ACM is the common mode gain, which they have given 48 and 2. So its answer would be, like, remember you have done log of A by B would be how much? Log A minus log B. So it would be the same formula we'll use, that would be log of AD, that is 20 log of AD they have given 48 decibels, then 20 log of ACM they have given 2 decibel. So the final answer is 46 decibel. I am writing here also. Its formula would be 20 log base 10 AD minus 20 log base 10 ACM. So they have given you the formula, the AD, and this one is 46 decibel. Now next move towards the question number 3. Okay, in this they said output of a certain circuit is applied as an input to the op-amp based inverting amplifier. Okay, if you know about it, inverting, we have two types mainly, inverting and non-inverting. Here in the inverting, voltage is connected with the negative terminal, feedback is also connected with the negative terminal. Feedback is represented by RF, input resistance is represented by R1, and here the voltage is V1, and with the positive terminal it will be grounded. So the output voltage is how much for the inverting amplifier? The formula for the output voltage is how much? V out is equal to, as you can see, its voltage is connected with a negative terminal, so it would be minus of RF divided by R1 multiplied by V in. Okay, now see what they have given. If the amplifier output voltage desired is plus 10 volt, means they have given output voltage is 10 volt. When then the input voltage applied to the amplifier, we need to calculate the input voltage. Assume that VCC is the supply voltage. We don't need to use this in this formula. RF is the feedback resistance. They have given 10 kilo ohm. R1 is 5 kilo ohm. To simplify, we just need to put all the values in this particular formula of inverting amplifier. So it would be 10 and 10 would be cancelled out. V in would be equal to minus 5 volt. So fourth is the correct option. Okay. Now this one is the question based on the comparator circuit. So you should know for the comparator circuit, you can note it down also this thing, that if V in is greater than V reference, then output voltage would be equal to plus, and if V in is less than V reference, then output voltage is equal to minus VCC. Okay. So what is V in V reference? I am telling you the standard diagram. This is positive terminal, negative terminal. Here will give plus VCC supply and here will give minus VCC supply. Basically, what is VCC? The output voltage should be in the range of plus VCC to minus VCC. Okay, but output voltage must be in the range of plus VCC and minus. So here we'll give the input voltage that is represented by V in with the positive terminal. With the negative terminal, we here will give reference voltage. Okay. Now this is the standard thing which I just told you, all this thing. Now see the question what they have given. They have given V in is equal to 3 volt, V in is equal to 3 volt, and output voltage we need to calculate, and V reference, as I told you, with the negative terminal, V reference is there, and how much they have given? 8 volt. So V reference is how much? 8 volt. So in this case, second condition satisfied, that V in is less than V reference, 3 less than 8. So output voltage would be equal to minus VCC, and minus VCC how much? Minus 10 volt. Okay. Understood this thing? Okay. Now the question number 5. Okay. Which of the following is not the ideal characteristic of op-amp? Op-amp has many different kinds of characteristics that you need to learn. You can learn it through your notes also or through my channel also. Now in this, as they said, infinite output resistance. If we'll have R equal to infinity, means current would be very less. At the output side, if current is very less, then there is no use of op-amp, right? What we want, basically, if it's an op-amp, we want that we should give less amount of current, but in the output we should get more amount of current. But they have said it opposite, so this is not the characteristic. All other are the characteristics of the op-amp. Okay. Now the next question. MOSFET, I skip it for the while being. Now I move towards the rectifier based question. Okay. So in this they said find the PIV. PIV is basically a peak inverse voltage. Okay. PIV is basically a peak inverse voltage for the diode used for the proper working of full wave bridge type rectifier when it is supplied with a 230 volt, means V1 is how much? 230 volt. Frequency is how much? Frequency we never use in this kind of question, but let's write down also. Frequency is 50 hertz. To a step down transformer, they have given the turn ratio. This is N1 and this is N2. And if you know that always will use uh, the secondary voltage for the calculation, right? But they have given what? Primary voltage. So by the turn ratio formula, we need to calculate the V2, the voltage at the secondary side. What was the formula? N2 by N1 is equal to V2 by V1. So it's a step down transformer. N2 is how much? 1. N1 is how much? Given 10. V2 we need to calculate. V1 is how much? 230, right? So simplifying it, we'll get V2 is equal to 23 volt, or you can do it directly also, that if it's a 10 is to 1 ratio and we have given to 230, obviously we can divide it by 10. So we'll get secondary voltage is how much? 23 volt, correct? Now they ask you the PIV. PIV is a peak inverse voltage that is equal to the Vs maximum. But we got this voltage as a RMS voltage. And you know the relationship between RMS and maximum, which we have studied in your BT also. Vrms is equal to Vmax divided by root 2. So Vrms is how much? 23 multiplied by root 2 is maximum. Correct? So you can solve this and then you will get the final answer. Got it? Now move towards the next question. 10th question. In this they said a sinusoidal secondary voltage of peak value of 10 volt. Peak value means the maximum value, and they said secondary voltage, so it is V2 maximum is equal to 10 volt. Frequency is how much? 50 hertz. They said it is applied to HWR means half wave rectifier. Load resistances they have given 800 ohm. Assume its ideal diode means diode resistance is. Calculate the average load voltage means we need to calculate V average. V average is how much? We'll have formula for the V average, that is V max divided by pi, or we can say VDC is equal to V average is equal to V max divided by pi. So simply we can do 10 divided by pi is 3.14. If we'll solve it, then it will 3.18 volt. The answer. Okay. If you want to know all the formulas, like for the half wave rectifier, for the center tap, and for the bridge type rectifier, I have written this over here. I know it's not clear, but you can take a screenshot. You will get to know about it. Okay. So this is up to here. If you want to learn more about the rectifier or anything, you can go to my channel, then you can get it. Now, if you want the solutions for the next questions also, then please comment. Okay.